Here's problem 2113. Air expands adiabatically, no heat in, no heat out, from a temperature of 300 Kelvin and a pressure of 100 atmospheres to a final pressure of 1 atmosphere. Treat the gas as ideal with gamma equal to 1.4 and determine the final temperature. Compare your result to the boiling points of nitrogen, 77.4 Kelvin, and oxygen, 90.2 Kelvin. Could this method result in the liquefaction of air? Alright, so we have a key here. It's adiabatic, and we're dealing with the initial temperature, initial pressure, a final pressure, and we're asked for the final temperature. So we're strictly dealing with pressure and temperature. In this case, our initial temperature times our initial pressure to the 1 minus gamma over gamma should be equal to our final temperature times our final pressure to the 1 minus gamma over gamma. Initial temperature is 300 Kelvin. Initial pressure is 100 atmospheres. And final pressure is 1 atmosphere. Let's solve this for our final temperature. Final temperature should equal our initial pressure divided by our final pressure to the 1 minus gamma over gamma times our initial temperature. Our initial pressure is 100. Final pressure is 1. Atmospheres over atmospheres will cancel out. We'll have 1 minus gamma, which is 1.4, over gamma, 1.4, times our initial temperature, 300 Kelvin. So this is going to be 100 to the, let's see, negative 0.286 power times 300. Or we can think of 10 to the 2 times this, negative 0.286 times 300, which would be 10 to the 2 times 0.286, negative 0.571, just a different way to look at it, times 300. So if I take 10 to that power, times 300, I get 80.5 Kelvin. That brings the temperature way down below the boiling point of oxygen, so you could liquefy oxygen. In this particular method, you wouldn't be able to liquefy nitrogen because that's lower than this temperature, but if you change your initial pressure, you could be able to create a condition where you can lower the temperature to below 77.4 K, and then you'd be able to liquefy the nitrogen as well.